The purpose of this PowerPoint is for you to attempt to complete a past paper question. It's split into 3 different sections. In the first section, you're going to be given the exam question, and the aim is that you just try it on your own and you see how far you can get through the past paper question. Hopefully you'll be able to do it all on your own. If you find that you're struggling, then you can move on to section 2, where I'm going to give you a few little hints and some tips on how to perhaps get started, so then you can have another go at the past paper question. And if you're still totally confused, then you can move on to section 3, where I'll go through the whole question in lots of detail. So here's the past paper question on arithmetic series. Press pause now and have a go at it. If you do manage to get through it all, well done. The mark scheme is at the end of the PowerPoint, so you can mark it. Once you've tried it, if you think you need some help, then watch the next slide where I'm going to give you some hints. But press pause now and have a go at it on your own first. If you haven't tried the question on your own first, then make sure you press pause now. But if you're watching this slide, then it means that you've tried the question already and you need a few hints to get started. So in question A, we've got an arithmetic series which has a first term A and a common difference D, and we've got to prove the formula for the sum of the first n terms. Now this is a proof that should be in your notes, it's in the booklets, but just to give you an idea of how it works, with an arithmetic series, it's a series of numbers that always increase by the same jump each time. So if we generalise and we call the first term A, then the second term would be A plus D. The second term, it increases by D, so we're adding D each time. The third term would be A plus 2D, and then it would be A plus 3D, etc., etc. So you can see that each term is increasing by D each time, so we call that the common difference. Now with a series, it means that each of these terms have been added together. So if I put a big plus sign in between each of these, so we are now adding those terms together. I'm going to write plus dot 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 because we would keep going until we get to whatever we want our last term to be. Now the formula that we're trying to get us to prove is the sum of the first n terms. So you need to think very carefully about what the nth term would look like. You need to fill in there what the nth term would look like. Now I'm going to leave that there for part A because I'm hoping that you're going to be able to find that proof in your notes somewhere and continue on with that. But I'm going to try and give you some hints now on part B. In part B, it talks about the sum of the first 10 terms. The sum of the first 10 terms could be notated as S10. And we've just proved a formula for Sn, so you can use the Sn formula but put n in as 10. So you should be able to use that formula from part A. And if you put in all the n's as 10s into the formula, it tells you that this is equal to 320. So we're using that formula from part A, we put in all the n's as 10s, and we know that the whole thing is equal to 320. Now when you do that, you'll end up with an equation that's got 2 unknowns in it. It'll have A's and it'll have D's. If there are 2 unknowns, then hopefully you're already thinking one step ahead of me. If there are 2 unknowns, you should be thinking about simultaneous equations. So with simultaneous equations, there are 2 unknowns, but we need 2 equations to go with it. And so far, we will have only written down 1 equation. So we need to now try and write down another equation with those 2 letters in. So the next clue that they give us is that they talk about the sum of the 12th and the 16th terms. So now we've got to try and write down what the 12th term would look like and what the 16th term would look like. So if you look back at what I was writing in part A, we've got the first term, we've got the second term, the third term, the fourth term. Can you try and write down what the 12th term would look like and the 16th? If you can write down what they look like and then add them together, you know that the answer is 166. So term 12, add term 16 equals 166. And what you should have then is two equations with two unknowns. So you should be able to use simultaneous equations. So then you'll know A and you'll know D. The question is find the first term, so they're asking us to find A, and the common difference D. So those are the things they want us to find. Right, press pause now, see if that's helped you to get started. Try and work through this question now on your own. If you're still confused, then on the next slide I'll go through the answers in detail, but definitely try it now on your own. Press pause. Okay, I'm now going to go through these questions in detail, starting off with part A. So first of all, if I write out what the series would look like, the first term we call it A, the second term is A plus D, the third term is A plus 2D, and then A plus 3D, etc. Plus dot dot dot, and then the last term for us is going to be the nth term because it's asking us to find the sum of the first n terms. Now the nth term would look like this, A plus n minus 1 d. So let's think about where that's come from. If you look at the first term, there are no d's. If you look at the second term, there's 1d. If you look at the third term, there are 2 d's. However, whatever term number you're on, the number of d's is always one less. So if we want to go as far as the nth term, then the number of d's will be n minus 1. So that's what our series would look like if we started writing it out. Now the next thing I'm going to do is I'm going to write this same series out but backwards. So I'll start with A plus n minus 1d plus, I'm just going to write dot 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 plus, and the very last one will be A, the one in front of it will be A plus d. So I'm just copying the line above, but I'm writing it backwards. So starting from the nth term, working back to the first term. Now each of these, because we've added each term together, could be called Sn, the sum of the first n terms, because I'm adding together the first n terms. Now the next step to take, which is a clever trick to memorise, is to add those two sums together. So if we add the two sums together, we'll now have 2Sn. And when you're adding your sums, add them in pairs. So add this pair together, then add the next pair together, add the next pair together. I haven't written all of them in. Add this pair together. What you'll find is that when you're adding your pairs, they all turn out to be exactly the same answer. They all turn out to be 2a's plus n minus 1 lots of d. Now there are n of those because each pair that I add together comes to this, but there are n of them because it's the first and the second and the third and the fourth and the nth. So there are n of those. So you could write this as n brackets 2a plus n minus 1d. The last step then is to divide by. Sorry, my computer went a bit funny then, so let me just write it where we were just at. So we had this. That's where I was on the last slide, and I was just saying that the last step is to divide by 2 so that we can get the Sn on its own. So if we divide both sides by 2, we could write this as n over 2 and then 2a plus n minus 1d. And that's the exact formula that we're trying to prove. So there's part A done. I'm going to go on to a new slide now for part B. Okay, so in part B, they're asking us to find the first term and the common difference. So they're asking us to find A and D. If they're asking you to find two different things, then there's a really good chance that you're going to have to use simultaneous equations. So if they give you two clues, and if you can write down two different equations, then you can solve them simultaneously, and that's going to give you two different letters. So the first clue that they give us is that the sum of the first 10 terms is 320. So what they're giving us here is S10. So I can actually use the formula that we proved in part A, but I can, instead of calling it Sn, I can call it S10. So I'm going to use that formula, but I'm going to put the n's as 10. So that will then become 10 over 2, 2a plus, and if I put that n as a 10, 10 take away 1 is 9, so I'll have 9d. And I'm told in the question that that equals 320. Now I could simplify that a little bit, because 10 over 2 of course is 5. So 5 times 2a plus 9d equals 320. And then I'm thinking we might as well divide by the 5 just to make it look that little bit simpler. If I divide both sides by 5, I get 2a plus 9d equals 64. So I've just divided there 320 by 5. So there's one equation. Now I'm going to try and come up with another equation. So I'm looking at the question, I'm looking for another clue. It talks next about the sum of the 12th and the 16th term. So it's not using sums anymore, it's not the Sn formula, it's just the 12th term on its own, term 12 and term 16. And it tells you that if you find the sum of just those two terms, it's 166. So I need to think about what would the 12th term look like, just the 12th term on its own. Well, the 12th term would be a plus 11d. Remember that the number of d's is always one less than the term number. And then the 16th term would be a plus 15d. And they tell us that if we add those together, it gives us 166. And then I can simplify that because there are two a's there, and 2060 equals 166. So I've now got my two equations that I can solve simultaneously. So I'm going to write them one on top of the other. I've noticed that the a's are already the same, which is really useful. I'm going to write the one from the right hand side on top. So if I write 2a plus 26d equals 166, and then underneath it I'll write the other one, 2a plus 9d equals 64, and then if I subtract them, the a's are going to cancel each other out immediately. So 26 take away 9 is 17. 166 take away 64 is 102. So if I do 102 divided by 17, it gives me an answer of 6. So D turns out to be 6. My last thing then is to work out what A is. So I'll go back to one of the equations from earlier. I'll use 2a add 9d equals 64. And I'll just put in there what I know. So 9 times d, 9 times 6 is 54. And then if I solve that, I can find out what A is. So 64 take away 54 is 10, divide by the 2 and we get 5. So A is 5 and D is 6.